Alrighty, we're going to talk about specific heat. And so we're going to talk about many temperatures, we're going to talk about things getting hot, and there's going to be a lot of numbers. So specific heat, just the basic definition, is how much energy you need to heat something up given its mass. 1 degree. So if we think about this, if you have a metal spoon in a pot and a wooden spoon in a pot, which one's going to get hot first? The metal one. Which means that you need less energy to heat up the metal spoon than you do the wooden spoon. So that metal spoon has a lower specific heat value than the wooden spoon. Another example, if we have a pot with nothing in it and a pot with water in it, the pot with nothing in it is going to get hot very quickly. So you don't need a lot of energy to heat it up. So its specific heat value is very low. The pot with the water you need a lot of energy to heat up that water, so its specific heat value is very high. So let's think about the beach. We even got some beach sounds to help us think about the beach. So when you get to the beach in the daytime, let's think between 12 and 4 o'clock, the sand's going to be really, really hot, and the water's going to be really, really cold. And so what that's telling us is the sand is absorbing energy very, very easily, so it has a low specific heat value. Versus the water, it needs a lot more energy to absorb all of that heat energy to get hot, so its specific heat value is much, much higher. And what we see when it gets dark is that the sand cools off very much so that it's very cold to touch, and then the water is actually much warmer than it was to start with, because it's been baking in that sun all day, absorbing all of the day's sunlight. It's finally absorbed enough energy to get warm. And so not enough time has passed for it to lose all of its energy, because it's losing its heat as much slower. It takes longer for it to gain energy. So the water is going to be warmer at night than the sand. And then there's math. So this is the formula that we're going to be using. Q is going to be our heat added, or the heat that's going to be supplied. C is our specific heat value that we've been talking about. Mass, that's how much stuff we have, usually in grams. And our change in temperatures, that's going to be our final temperature minus the initial temperature. So you're like, Miss, I've never been to the beach, I don't know what you're talking about, this sand and this water thing. So we have an experiment to look at to show you exactly what I'm talking about. So we have water, we have sand. I'm going to estimate that they're the same mass, they're getting the same amount of energy. And so we see they're both heating up, but the sand is heating up much more rapidly than the water is. It's almost 20 degrees hotter now. And then we start to cool it, and we see that the sand is dropping in temperature much more rapidly than the water is. And so when we start to do the math, we don't know how much energy they're putting in. We do know the specific heat of water. We're going to round that off to 4. I'm going to estimate that the mass is 200 grams because the water level looked about 200 in a 250 mass beaker. That initial temperature was 24 degrees, and in the heating process, the water got up to 41 degrees Celsius. Then we work it out. We have our specific heat value, the mass, and our change in temperature. We subtract these two, we get 17. We multiply the whole thing out. The grams and the grams cancel. The C and the C cancel. We're left with joules. We get 13,600 joules, or 13.6 kilojoules. So now we can solve for the sand, because now we know how much energy they supplied. We know that there's an equal mass of sand. We know the initial temperature of the sand, and we know the final temperature of the sand. So instead of solving for Q, this time we're going to solve for C. We just plug everything in and solve for C this time. So here's our Q that we already solved for. We don't know C, equal mass, and the change in temperature. We do the subtraction, we get 34, multiply, divide, and we get 2 joules per gram Celsius is our specific heat, which makes sense because that's twice as low as what we saw with the water. The water was 4 joules per gram Celsius. So that means that we need 2 times as much energy to heat up the same amount of water to get to the same temperature as sand. And so that's why the specific heat of water is much higher than the specific heat of the sand. So bottom line, you should always be given 3 out of the 4 variables. Plug and play, find out the one that you need, using some algebra. And if you have a high specific heat value, that means you need a lot of energy to heat the substance up. So I'm going to give you a minute, pause the video, you try to do this one. So we plug all of our stuff in. Here's our values. They give us kilojoules, but our answers have joules, so we'll just convert that by multiplying by 1,000. They give us a mass. They give us temperature 1 and temperature 2. We plug all of that in. We solve for C. Subtract, multiply, divide. We get 1.73. So your answer is C. So take a break, and then you can watch the next video. Waiting for water to boil, like, it takes ages because water has such a high specific heat.